Well, welcome everyone. We're going to talk about how new startups can build the next great IoT chip. So this is kind of a little bit unique presentation in that we're going to, with startups you tend to talk about things like, well, we'll do it in a board or something, but there's been research and a legitimate proposition that we can actually do startups with chips. And that's going to be today's discussion. So I'm going to give each panelist just a couple of minutes to introduce themselves and a little bit of their position, and then we'll go right into questions. So why don't we start at the end here with Frank?
Okay. So my name is Frank Schirmeister. The accent is German, but I do actually live in San Jose for the last 17 years and try to get rid of the accent, but it has its uniqueness. I'm leading the product management team for parts of the system development suite over at Cadence, and we are involved in verification of IoT designs. And perhaps to just define a little bit how Cadence views IoT, it's really a combination of IP, implementation, and verification. We're working very closely with ARM on things like joint reference designs. We can talk about those later. And the joint implementation and verification flows. And it's really focused across the whole spectrum of IoT, right? So there are the edge nodes, the trackers. These have various degrees of complexity in themselves. Then we are basically working with ARM closely in the hubs, the mobile phones, the cars and so forth, which take your data, get them to the cloud. And then, of course, there's servers, where you do server and networking solutions in there. So that's kind of defining the whole IoT scope. I think today for startups we'll probably focus a lot on the edge node pieces and the systemic aspects of it.
All right, thank you, Frank. George?
Hi, I'm George Zafiropoulos. I'm the Vice President of Solutions Marketing at National Instruments, focused in the semiconductor market. And in our world, we focus mostly on device testing, both at the die chip level, also at the production volume chip test. And we see a big increase in demand for IoT product development and test solutions. And we're also working with EDA companies like Cadence into figuring out how to more effectively go from design to test. So some of the areas that we're focused on relative to IoT is figuring out how do we drive the cost of test down, because test cost, both testers and the time on the testers and the setup of the testers is very, very expensive. And one of the big drivers, especially on the edge part of IoT, is driving that cost per unit way, way down. And you really can't afford a large fleet of very expensive test equipment. So we're focusing on figuring out how to make test more cost effective. The other thing in IoT test is also raising the test from the traditional old-fashioned pin electronic test to more system-level test. And these days with IoT, that often means doing testing through the RF port all the way down into the internals of the design. So it's not your typical electrical probe kind of testing, but may actually be protocol and maybe RF-centric ports on the device to do that system test. So we're looking at all those things.
Great, thank you. Nandan?
Thanks. So I'm Nandan Nambali, VP Marketing Strategy at ARM. And looking around, most of you didn't attend the small pitch I did before. But ARM, as I said, views IoT not as a segment on its own, but effectively a very diverse way of delivering services to connected devices and a much larger level of connectivity between them. And effectively, any endpoint has some sensing, some compute, and some connectivity. And all the parts in between are going to have some compute and connectivity. So ARM's focus on this is to do effectively 2 or 3 key things. One, provide IP, that is compute, as well as entire system solutions that are tuned to purpose for very different PPA points, or performance, power, and area points, because these requirements are very diverse. It is to provide the key aspects of foundation for it, which is security built into the hardware fabric and components that can be built into the SoC, and safety. Now, sit on top of that is the ability to connect that device securely to the cloud or through the network. And we have technologies that are now both through product as well as open source that we've been able to provide endpoint security as well as transport layer security or transport security layer up all the way to the cloud. If you put it all together, and as he said, there's a lot more interest in IoT, especially in the chip world. We're trying to make sure that that access is easily available. We started our Design Start program to enable a lot of the startups or entrants into this space that want to design their own SoCs, free access to design for the low-end microcontrollers, along with support and system design so that they can actually take these things to market sooner.
Oh, great, excellent, thank you. Let's go ahead and get started. So, cost-sensitive startups and perhaps even board manufacturers that want to move to a chip and want to get into the IoT, it seems like, it's going to be a very difficult and expensive thing for them to do. Maybe that's a place to start. What are some of the obstacles that the startups would see or would expect?
Well, I think the first obstacle is just the cost. The cost of first article manufacture is the big hurdle. So in traditional IoT applications, they've really been board-oriented systems where you pick an MCU and you pick a radio and you pick a sensor and you integrate it, and if it doesn't work, you make another board, and so for $1,000 you get a new spin. So that's been a very cost-effective approach. But as the market drives to smaller, more energy-efficient implementations, you have to go more integrated in silicon. And so overcoming that NRE cost, I think, is really the biggest hurdle for a lot of these little companies.
Well, NRE cost, yes, one, but then also it is tough to define monetization up front. So I think if I look at the cost of design, I always need to figure out the return. And it's actually quite interesting. I may not get, right, so I'm taking out, Cadence has this challenge thing. I have apparently done 13,450 steps already. And but the chip in here, you probably won't monetize on it by itself, right? So it becomes part of your overall cost equation. So one of the key challenges actually to figure out where to monetize, right? This thing ends up connecting to an app on my phone, which sends the data somewhere in the cloud, and I'm part of a team of 7, and we have over the next 3 days, the target is to do an average 100,000 steps per day between us 7, and then we get a virtual reward, right? So this is a gamification of health somehow. But for the startup doing this, the question becomes, how do I monetize on my investment? And then where do I have to invest? Is it the app talking to it? Is it the chip doing it? And then to George's point, absolutely, lowering the hurdle to design costs and verification implementation cost is huge, and that's why we are working together as partners and companies to bring this all together, bring the right IP together, the right flows together, and make them available.
Yeah, I think it's effectively the same, I would say. Initial funding and time to money, right? You can get past the first hurdle. How long before you get to volume? So there are effectively two things that you need to get through. And the other piece I kind of mentioned in my previous talk is that IoT is not one thing. It's a lot of things. And you can design for one vertical, but that vertical may not be enough to sustain you. You need to be able to design something that is applicable horizontally as well. So some of those challenges exist. But one thing we can certainly do is lower that barrier to entry. Right? And to that effect, when we talked about the Design Start program, we were enabling free access to start your design, a very cost-effective board to be able to prove it and actually get your funding further, and then a very low-cost access to both the IP as well as there are, especially for IoT, where it's defined by where flash is more acceptable in your node. These are not the very bleeding edge nodes. So you can actually get MPW wafers to get started and get it going. And once you have that cache, even things like Kickstarter programs go forward with it, right? So Pebble, even though they didn't build their own chip, did that Fitbit So you can see it's not just a silicon startup, it has to be a solution
Right.
that is needed to make that fly.
Yeah, not to be overly German about it, but the title of the panel is almost a bit misleading. It's actually not necessarily always about the chip per
it's about the
se.
solution.
I think we as vendors care a lot about it. They have IP, we have IP and tools. They have test environment for it. So we do care about the chip a lot. But then there's in parallel a conference going here on software virtualization and IoT and so forth. So it's really about the systemic aspects of how do you get to money, like Nandan said, time to money, and the how to lower the initial hurdles.
So that really means the customer's different. This brings in a different class of customer. A customer who would never make a chip because it's not their business to make a
Exactly.
chip. It's merely necessary to get the kind of thing that they ultimately want in their product.
Exactly.
So, you're right, especially at DAC here, right? The ghost of Moore's Law and everything. If it's not 10 nanometers, well, why should we care about it? But the IoT space is exactly why we should. So I understand it's bigger than all that, but still, in the mindset of a lot of startups, I think the fact that they could actually do a chip, is not expected. And as a matter of fact, I hope I get this right. Out of MIT Labs, now they're encouraging and there's a cost. There's some breakpoints you can look at where they encourage their those kinds of startups to actually do a chip.
Oh, absolutely,
for cost, but also for security reasons.
Right.
Now there's a lot of argument here. If you talk to a bunch of patent lawyers and whatnot, you're going to get a different answer. But supposedly, doing it in a chip is going to be more difficult to reverse engineer and whatnot than say on a board or something.
Right. Yeah, security definitely. And I mean, I attended the later part of your presentation, Nandan. Security, there was Mike Mueller's quote, is huge. So if you have it on chip and you can decrypt it from a bit file for an FPGA, that certainly is helpful. So security, safety, big items there, absolutely.
Yeah. And I think so we talked about IP and tools, but also if you look at 65 nanometer or 90 or even 180, you can actually get pretty competitive pricing on MPWs, right? You're not going to a million units immediately. You're going to a few hundreds or potentially thousands. You can actually get a very useful return on a very small investment.
Right. And that's just to add to that, in terms of flows, we see a clear bifurcation, if you will, in design starts. You mentioned, like, if you don't design for 10 nanometer, why you're even here? Well, I don't see that. I don't see that as necessarily true. Nandan did phrase it very well. IoT is not an application domain in itself. We see it the same way. It goes from medical through wearables, through consumer, through mil-aero even, and things like that. So it goes across the application domains. And one of the big trends I would see in EDA, and I think this is similarly true for testing and what National Instrument does, is the increased focus on application specificity. So for a design in mil-aero or design in automotive, I have to fulfill specific needs of testing of functional safety, for example, in automotive, which directly reflects itself into the flows which we're making available, right? So some of the things, Nandan mentioned the Design Start initiative and the whole hosted access to design. Those are important aspects to lower the hurdle and to make it very applicable to your type of application.
You're talking about it's much more systematic and it's very dependent on the application. Certainly the digital part of it at the higher nodes, 180 and whatnot, is very cost effective, and there are actually curves that you can get from various design houses that will plot that point at which it becomes more cost effective, say, over boards or over other nodes. The other part of this is IoT anyway, is that it's connected. So the connectivity piece, how do you do that RF piece? Is it a separate die? I mean, there's the issues of the stacked dies and whatnot. I don't know that we've talked about that a lot, but those are well at the higher nodes as well. So maybe we should have included Amcor or something.
Well, there are other people in here. So
company.
one of the cool trends in here is how do you actually put the different technology needs together? And I've mentioned those guys a couple of times. There's a company down in close to Irvine, I think Sunrise Micro. So they are a company which essentially takes dies and has very efficient ways to put the dies together. So suddenly all the technology aspects which you have by making sure your analog might not work well in that technology node and so forth are going away, because you can stack these things together within a die in a very cost-effective way and in a very small way, right? So some of the applications they were describing are so small, I didn't even think of it, that there might be a sensor and a component in there. And it's all integrated as a set of dies, and they even have a library of dies you can assemble. So there are really new techniques out there making this possible and reducing the cost for that.
So I think there's really going to be, in a way, a bifurcation of those implementations. There will be applications where the volumes are so enormous that you can drive everything to a single silicon die. And you'll have the radio, you'll have the microcontroller, you'll have the maybe even the sensor, depending on the kind of sensor perhaps, integrated into a single device. And then there will be other applications where maybe the volumes are not quite as big. And this is especially true when you have a whole host of different sensor types, because you're never going to put all the sensors in a die. It may not be the right material to do that with, where you will have a core that's the MCU and the radio perhaps, and then a different device, which is your sensor, that gets all packaged as one. So I mean, I could really see that combination of we can call it a hybrid. Well, what were the words we used for the last 30 years? MCMs, hybrids, SIPs. I mean, it's all the same thing at the end of the day, in that it's different things stuck together in one package.
Right.
So it's just another wave of that.
So I was thinking, George and I were at the IEEE IMS event and a couple of weeks ago. So this is a big RF wireless show. And they had the Dr. Cooper, right, I believe, the inventor of the cell phone, and his talk was on the death of the cell phone. Well, one of his points was that, the cell phone in the future isn't going to be a cell phone. It's going to be spread out over your body, right? So that maybe a server on the belt, and you'll have a RF thing sticking out. Well, I guess it won't stick out of your head, but maybe the glasses. So this idea that the wafers don't all have to be stacked together is very realistic, I think.
Absolutely. But not to forego to Nandan's. I mean, calling it a design start initiative, as Nandan gets, there's really both elements, right? You want to find the best cost entry, and what ARM with their partners have done with the design start initiative lends itself very well to get over the initial hump and really focus. This is why I'm excited about it. Really focus on the design problem you have, the system problem you have, as opposed to having to figure out, how do I use these tools? And because we are providing a flow, we are providing the IP from both companies, and we are making it accessible in an easy way. So you can really focus on the problem at hand, as opposed to figuring out how your hammer works, right? In a tools kind of comparison.
And so to that effect, we also have, we did the Bluetooth radio 802.15.3 as well with our Cordio product. And in fact, I was slightly confused initially when you talked about Sunrise, because Sunrise Micro is the company we acquired for that Cordio.
That's the guys. Sorry, no, that's a different name down in Irvine. You do assemble it.
You're right. Sorry. I know who you're talking about.
You're off the panel, Frank.
No, but that was a useful segue. So you will have actually RF components available in libraries, as you say, to put on the same die as well. And usually, as we say, it'll be in 55, maybe 40, but actually more so back, because that's where a lot of these things that have connectivity come in. But then the other innovations of how you put these things together will come in as well.
So this might also be a little overwhelming for somebody just saying, I just want to build a chip. Are there any questions? No? Nobody like that here?
So actually I have a comment, though, which is that points kind of back to the different sort of customer potentially, where the person that's looking to figure out how to do an IoT product, they have so many things to worry about. The chip is only one little piece. And so the availability of the reference designs and a known good working platform, so they don't have to invent the integration of the platform. They don't want to bother with that. It's kind of like when software really took off. It's because the PC or the Linux platform, it's like, okay, done. We don't have to build our own computer now. We can just focus on the software. The IoT companies are going to want to just take the hardware platform and use it and build all their value add on top of that. and leverage all that technology someone else invested in.
Right. And just to use the IoT to fix my mistake immediately, it was Indie Semiconductor down there who do
Indie.
Indie. So I thought down south the sun's rising. That's why I thought sunrise. But obviously that's the guys from Florida, right? Who do the Cordio pieces there. So, but it's interesting, different hurdles, which makes it actually almost like an education aspect. How what is the best way of implementation, right? It's not trivial, and then figuring it out in the context of the system is a challenge. That's why making these things available by partnering is, I think, great for helping startups there.
Agreed. And to the other point, having a good reference starting point, where especially a lot of those things are not really differentiating. You then focus on the things that are.
Yes.
And so the rest of it has to work. So somebody from analog mixed signal coming in and saying, I want to build a digital version, they can focus on it, but the digital portion is well tested, ready. So the design start portion, as well as I think Cadence has their own sets of reference platforms of pulling IP together. They're tested, known to work, and then you plug in the things around it. So you have to make those parts, the non-differentiated parts, quite easy to work with.
Right.
And is that happening? So I'm thinking, what kind of devices are you seeing that are doing part of this design start? And I remember talking to, I think it was Jürgen or somebody, that they were telling me that that fans now have these tiny little
tubes,
ARM or Cortex M to, I guess, adjust the speed or something. But the big deal there was that it would eliminate one of the wires, and if you can eliminate a wire, and the cost is about the same, you're ahead of the game. So
that's right.
Yeah.
Anything, I don't know. Other examples? I'm just thinking of chips that have been using the design starts and that fit within this IoT context, from the sensor all the way up.
I think you certainly see that in the MCU and the radio.
Right.
The sensor, the array of potential sensors is still kind of too broad to just throw the sensor in there necessarily.
By itself.
By itself. But virtually every one of the companies that focus around the MCU space have moved to platforms that are MCU plus RF. And it used to be like, we only do the MCU. Then we bought a company that also made the RF chip. Now we make a die with both of them together. And that's kind of where it's really at now. Because as a consumer, if I'm building an IoT product, I know that stuff's going to work. And so I feel much more confident in not having to reinvent what combination of stuff is going to work. And that's not only the hardware working, it's really the software stack. It's having the IP stack, it's having the Bluetooth stack, it's having all that stuff, available off the shelf. And so the stakes have gone up for the silicon platform providers to be really a system platform provider. Because you're really buying into that system ecosystem.
And then the APIs almost make it transparent. So one of the things, that's this aspect of virtualization, right? So if I look into things ARM's doing with Embed, which is available across platforms, right? So you get now a layer of access almost like on your PC. I need to access my drive. I won't write the low-level drivers, right? I want to get my higher-level APIs for that. So that level of software virtualization again makes it possible for the startup to really focus on their differentiating aspect, because putting together the sensor and the microcontroller together in itself, somebody has done already. It's now about how do I use it in the system context? How do I optimize the implementation potentially when I'm getting to volume and so forth? And that makes it then really possible for them to focus on their actual problem for the value of their end customer.
And the requirements for the MCU guy is changing too. I mean, I know you guys live this every day, but used to be you could just pick your favorite processor and you'd write some code and you'd ship the product. And now, if you can't do over-the-air updates, you've got to bet, that's like, have to have that. So just the bar on the basic feature set for that device is going up.
Right.
This is getting a little out of field, perhaps, but I mean, we're talking about the fact that the IoT is not just an end node, it's not just a cloud, it's all of that. So do we have the tools that would allow someone to think in those ways? Someone's putting up a chip or thinking of the application, can they think of, well, geez, okay, do I really need a chip? Or maybe I just need a smaller chip, I'll run this on the cloud and that one. How would you help a designer do that? And I mean across the whole space, like what about the RF part and all that? I mean, you almost want some sort of system or requirements management or something. I guess.
It's funny, we know each
Simulation, at
other
least.
from the old days of system simulation. Remember, 29 years ago, 97? Wow. Gary Smith and all the system simulation aspects at the time. You had tools like Bones, you had tools like iLogix at the time doing these system level tools. Some of that finds a revival because similar tools the IT provider would use or your internal IT department would use to figure out how to configure the servers across the different buildings on your campus. It's a similar set of problems to figure out if I have suddenly 1,000 edge nodes coming into the hub space, how do I do all the scheduling? Do I have enough bandwidth and so forth? So there's certainly a revival of some of those system level type tools happening to assess the performance of how the edge node interacts with the hub. Do I have enough bandwidth? Do I have enough storage? Or even to figure out, that's very important in automotive, when you have these sensors in the car, figure out what processing happens where, right? Do you really want to send all the pixels of a camera over the network, or do you invest more into pre-processing and then send some condensed, compressed information? So those are interesting architectural trade-offs at the system level for people to look into. And it's kind of a revival of the old Ptolemy type tools to do that level of system level assessment.
Yeah, so I mean, to add to Frank's point, apart from the simulation, often the devices available today become the platform for saying, here's what's broken, right? So analysis on actual components or actual end devices is what's saying, here's an opportunity because this is where this is all used, right? For example, the watches were cool and novelty was, I can do it, I'll charge it every 6 hours, right? But with that kind of battery. And then it became, it's useless to me if I don't have a couple of days battery life, and okay, how do I do it then? So the analysis beyond that is going to be, okay, here are the points I can save. Can I do it on a MCU product with flash rather than DDR? Those kinds of things are at the top level. Now, after that, I think the ability to do, how does this system scale for that? Those are the tools that we can provide. But I think a lot of the drive is going to come from the top down about where the opportunity is to improve.
Right.
That's a good point. I mean, it'll be a look at efficiencies, right?
Yep.
You could do it with this particular one, but if I shift the bandwidth, well, not bandwidth, but if I use a low power Bluetooth or something, whatever it happens
and
to
as
be.
you said, if I can take off 2 pins and that takes me to a lower package, then I'm going to do that.
Any questions? Panel of experts up here. Shame to have it go to waste. Okay, I'm sorry, I saw his hand first.
My question is, with these chips selling at less than $1, where do you see the profitability of that?
Oh, that's a great question. So the gentleman's question is, if price points are being driven down on IoT to, let's say, the dollar price point, where's the profitability going to come? And that's a great question. It kind of goes back to what Frank said early on, which is maybe the way you make money is not I'm selling that chip and that I'm in the chip business, but I'm doing something else, and the chip is a part of my other thing. Is it that the IoT device is at the edge is making money, or is it the cloud service that's making the money, or the application layer that enables something else? That's certainly one path. I think that's a big challenge for a semiconductor company doing an IoT product, because if your total sum value is I'm a chip company, then you really have to come up with some differentiating value. So in that differentiating value is not going to be the MCU and the radio. It's going to be the network architecture and the other point Frank made about the system complexity. So I've worked with IoT chip companies who say, oh, well, with my wireless 802.15.4 network, I can support 512 nodes. And I said, that's awesome. Have you ever built that out? Well, of course not. No, we've only ever built it for 64. How do well, hypothetically, it will work. So there's a lot of challenges at the higher level. So I think the people who can prove drop-in functionality, reliability, without a lot of futzing around, they can command a price premium. The companies that ship product where it's not very well documented or it takes a lot of work to bring it up and get it working, they're going to have a hard time because they're going to be driven down the price track. And that's kind of a miserable place to be. So I think if you're a pure chip play, that the value add is how can you make that a more powerful product for the end user. And by powerful, I mean does what it's supposed to do, but it's really easy to integrate and to scale. And if you can do that, I think you can command an extra price premium. But going down the low cost, I mean, you can buy a Wi-Fi chip module with an MCU for $2 from China today. That I think it's pretty cheap, but they're not exactly the easiest things to work with.
Yeah, almost certainly. I mean, I'm re-emphasizing the point I made at the very beginning. There may be cases where, as a semiconductor company, you have a combination of a product which is so broadly applicable that it makes absolutely sense, right? A special sensor combination, you have an M4, what have you, some Tensilica DSP-ish processing, some of the IP to put it all together, and you have a really cool product which is applicable across application domains of the IoT. But I think there will be most certainly a class of companies. My favorite example there is one product I use from a company called Beddit, which is a sleep tracker which goes under my sheet. My daughter was really worried. She did a sleepover in my room once and then she decided never ever again my dad snores. So, and he snores bad. It looks like he stops breathing at night. So I'm like, oh, that's sleep apnea. So let me fix that or observe it. So I got the sleep tracker. It's a $120 product at Bed Bath & Beyond. It has a little chip together with a sensor under your sheet to take your heart rate. It connects all night long to my iPhone. That's why it needs to be charged. And then I get an email. I was in the top 20% sleepers last night, and here is whatever the length and my sleep efficiency was. So if I now, that's a $120 product, but for the whole system, right? So somebody had to write the app. Somebody had to has to run the servers to get me the data. I'm actually not paying a monthly subscription fee yet, right? So that may come from a medical perspective. And the chip is part of this overall assessment. So my impression was, may have just used an ARM-based microcontroller originally in there. If their volume now explodes into reasonable volumes, they will most certainly optimize the price of that component of the overall system. Agreed. No question. That's one way for them to drive their costs down.
No, agreed. I think the assumption that all of these are sub-dollars is not the right one. The ones that are in crazy volumes that are not necessarily differentiated are probably the ones that do. And so I'm probably reiterating what they said. One, the specialized components, let's say automotive, that has a safety requirement, etc. Right. You are going to get your margin for it, right? You may not have the same volume, but you'll get your numbers for it. For the other ones, you are the mindset change is it's not a chip startup. It is a solution startup. Right.
And you can command a premium for that. That's
where the huge premium. And then, I mean, these guys, I want to see their business plans somehow. So you find some of them on Indiegogo and so forth of what they're building, right? And it's interesting. Their business plan, I'm sure, includes at the end, like, I monetize on the data what I sent them. And yes, the healthcare pays for part of the medical data, go to the insurances and what have you, right? So there are interesting ways then to monetize, and the chip becomes a central component, but you really need to look at it more systemically.
I think we had one more question.
Right. My question was really about OTP and flash usage in IoT nodes. Do you see them being separate or one replacing the other in many applications?
OTP and
talking
flash?
About OTP, yeah. Or
Well,
there's no trend.
I guess my only comment is that you have to be able to push software updates over the air, and that implies you have to have some kind of reprogrammable flash.
Right.
So OTP doesn't buy you anything.
For security, it might be.
Perhaps for parts of it, yeah, there might be parts that are OTP, but for and there may be some applications where over-the-air programming is bad because that's a security hole, and so I'm sure there are some class of problems where that's not a good choice. But for virtually any kind of normal consumer or industrial application that's not controlling your nuclear reactor, perhaps, then you need that kind of access.
Right.
So you need some kind of flash or programmable memory.
It's coexisting.
Yeah, I think it's coexist, and we verify both. I'm kind of neutral on that one. We help verifying both solutions. So
So if you had to sum up our little chat here today, what would you tell to the startup, just in a couple of sentences or a couple of minutes?
well, from my perspective, I think it's going back, figuring out where the real end customer value is, and then distribute the processing and the cost right across the components. Right. If I have the ability to do everything with an existing speed tracker, or I'll build it on top of my whatever my favorite Fitbit or whatever piece, or it may be based on an iWatch, whatever. I can monetize on top of that with my systemic approach to my startup. So figuring out what the customer actually pays for and how do I differentiate myself and make sure things are secure. Like George said, if nobody attacks Fort Knox, they never go for the servers. They always go for the edge nodes. So if you have special security requirements like in automotive or in the military, then you have to be very aware of that.
I think for me, I think it's really all about the platform. It's all about the completeness and the ease of deployment of the platform. And I think the companies that have the best, there's a certain minimum functionality and performance you have to have, but once you hit that, then it's all about what else can you give the IoT developer to give them a full head start, not only in hardware, but in firmware and in software, right down to how do you do device authorization. So I have to serialize every IoT device out there, and how do I assign the address to that thing? And some of them do that in Flash, where there's a manufacturing line and you zap everything that flies through the line. Even those tools have to be provided. So I think the bar is, the old days you get a microcontroller data sheet and like, good luck with the assembler. Those days are way gone. Now it's all about, I want the platform, I want all the tools, and I want to come up and get up and running with a prototype of my thing really quick. So I think the more you can focus on the complete ecosystem, your own ecosystem of stuff, and maybe third parties, then the better off you're going to be.
I would say the market just got bigger.
Right?
Because it's not your traditional silicon startup, right?
That's right.
It is the silicon capabilities added to a solution that is bigger, right? So begin with the end in mind, effectively. It's not I'm trying to push a chip. I'm working with people who know how to solve a different problem and solving their silicon problem with it, right? And for that, I think, as we said, getting off ground is important. And especially for a company that's focused on service, this may not be the biggest cost they want, right? So use things like Design Start or hosted design services to help with that. Actually getting to market with a chip, especially for proof of concept, is not that difficult, especially with the back end of it. And then focus on the ecosystem that gets you there first.
All right.
Right.
Cool.
Excellent. Well, if there's no other questions, then thank you, gentlemen, very much.
Thank you.
Thank you.